Welcome back to Big Flippers, where I'm always your host and I'm still Mike. In this episode, we'll be resurrecting a nearly dead channel strip. We'll be taking it from zero to hero with a full recap and op-amp upgrades. I'll show you my tools and my techniques for how to do the job, and we'll even squeeze in some audio examples. Grab a cup of joe and your favorite bottle of bourbon, slug it back with your cat, and let's go.
This is channel 12. As you can hear, it sounds pretty messed up. The gain is actually turned up all the way and the output is very low. It's not even showing up here on the meter at all. It's, pretty much a bad channel.
I can walk us through some of the features like the EQ, but really it's not going to be doing very much because this thing sounds so bad and is barely even working. But if we come down here to
the channel, now the EQ is engaged and we can test it out to confirm if it is working, and it is. We have a channel that kind of works, just not too good.
What I have here is invisible glass. It's an excellent cleaner for these faceplates, and I particularly like this one because it's made by the greatest brand of all, Stoner. I've seen cleaner stripper poles. Okay, that's good. Now look at it. I'm gonna clean the pots and the switches. And for this, I have this lubricant and electronics cleaner. This is Max Pro. You can get this stuff on Amazon. All the links will be in the description. I'm going to go through these right now and just kind of give them a little squirt right in those cracks. Get right around here too, and I'll give it a few turns. And then I'm just going to tip it up and give it a few more turns. That one's good. I'm going to move on to the next one now. And if you're looking right at these little cracks right there, as hard as it may be to see, it is actually going in there. I can see it flowing in. That's what we want to see. I'm trying to go gentle with the nozzle. I don't want to overspray and create a huge mess. I'm going to come in here on this back side and try to shoot in any open area in the middle, like right here, and then also right in here. And I'll work the switch a few times as I do that. Okay, and then I can just kind of come in here and clean up. It'll pick up some dirt too. It looks a little bit yellowed already. Don't leave behind any particles. Okay, now that I've gone through and cleaned all of these switches, I'm gonna just go through with a Q-tip and clean up my mess. There's some overspray. I wanna make sure that I just tidy this up a little bit. The next thing to work on is the actual recap. I'm pretty confident that just a recap is gonna make it come back to life. And to test that, we'll hook it back up to confirm before I move on with any upgrades at all. Right now I'm about to do a recap, and I'd like to point out a few things. It looks like this has been partially recapped in the past, but they're still fine, and I'm gonna just leave them in there for now until I replace the older caps. I noticed that this one, and this one surrounding the SSM 2017 chip, these are definitely audio caps. So both of these are original and they're pretty old at this point. This was made in 1995. So I think they probably should go, and they may even be the culprit. When you're dealing with an old circuit board, some care needs to be taken not to damage the circuit board. So I've got a way of doing this. I'm going to demonstrate that right now. The tool that you're going to want to use is a desoldering iron, which this is a desoldering station. It's a fairly inexpensive one that I got off of Amazon, and it works. You don't want to use one of those plunger type spring-loaded jobbies. That's not going to cut it. You're going to probably trash your circuit board. This big old black cap right there, I'm going to start with that. This cap is part of the gain knob, which is right here, mic gain. So it's part of that signal path. See, I'm wiggling a cap just like this. I'm not sure if you can see that on camera. But while I do that, I heat this up and then I pull the trigger. Little demonstration. And just like that, the cap comes right out. It's perfect, you know, so there's no damage to the board. That's really important. You want to work quickly, you want to have some techniques that work, and then it's all good. But if you just carelessly come in here and you try to start removing caps, you're going to damage things. So that cap's out. The next one to go in is a modern day equivalent. It's definitely better than this old cap. When putting in polarized capacitors like this, and this one is known as an axial cap because it has an axis, whereas most of these other ones are radial caps. Arrows and a negative symbol indicate that this is the negative lug. On the circuit board, it indicates the positive lug. We're just going to make sure that we get that correct. Goes in just like so. Give it a little tweak if you like so it doesn't fall out. It's best to use the soldering station in my opinion because you can adjust the temperature. If you're dealing with just a regular old cheap soldering iron that doesn't have adjustable temperature, you probably should not be working on these vintage circuit boards. They're very delicate, and if you just overheat these pads too much, they're going to fall right off, and then you're going to really be in a pickle. We are up to temp now, so as you'll see, only on there for just over a second it seems. So I'm going to snip that off with my magical wire cutters right here. They're not really magical. Leaving a little bit of room above. And this little guy can go in the garbage. I don't like to save these. So the first one's good. Now we're going to move on to the next one and slowly cover all of these caps. And it's the same process for these radial caps. I'll demonstrate one more time. With my index finger of one hand, I will gently wiggle that while looking to see where the pins are. I see where they are. We want to heat up the pad, wiggle, and suck. Repeat. Heat up the pad, wiggle, suck. That one came out easy peasy. These new ones that I got are some pretty nice ones. These are Nichicon Fine Gold caps. Yeah, those ones, man, they sound nice, right? Nah, all electrolytics suck. Now that I got my cap out, we want to check our polarity. It's always labeled right on the circuit board conveniently. We're going to make sure that our cap goes in there with the correct polarity and bend the pins over so I can work with this for a second here. And with my solder, I'm going to just do that. All right, and I will continue on. That one's out now, no problem. The circuit board looks really good. So I'll just go ahead and grab another one of these brand new shiny gold Nichicon caps. But for now, just gonna work on this one channel. This is our channel 12 that has now been cleaned side by side with channel 11, which is stock and not cleaned. Channel 12 has now been fully recapped, and as a direct result of that and cleaning all of the pots and switches, you can hear channel 12 has come back to life. It now works perfectly. It sounds really gorgeous, actually. I have the gain turned all the way down. Hear how low noise it is. I was pretty darn sure it was those caps. So now at this point, it's actually safe to proceed with the rest of the modifications. We're going to upgrade the chips and upgrade the VCA, and then we can really hear the difference between these two channels. Let's take a listen to this EQ. I'm going to have to hit mids to channel right here. And the EQ is now on, I believe. Check, check, check. It certainly is. Can you hear it? Because I can, and we can sweep through these frequencies, and it sounds way better than it did before. It's working good now. Now we're going to just confirm, now that we already know that our EQ is working just fine, if the fader works. I'm going to engage fader flip, and you can bring that up while I'm talking to see if our VCA is working. So that's what this is testing. It tests the VCA. It's working. I've already removed this, the mic preamp chip. It's a PMI SSM 2017. These chips are okay, but that's the sound of the mic preamp, and it's kind of outdated. The chip that I put in here is a VAT 1510, which I really like the sound of. These are better mic preamp if you're looking for clarity, and I think you are with a desk like this. One of the other things I'm going to do is with these two smaller caps, these are 0.22 microfarad WEMA caps. I'm going to use those as bypass caps on C22 and C25 because these two are basically hugging the sides of the mic preamp. These are both electrolytic caps. I put these in here and they're very good caps, but they're still not as good sounding as a film cap. We can bypass the high frequencies, basically allowing the high frequencies to choose this 0.22 microfarad film cap. I'm not going to do it for the whole thing. It's a waste of time, and most of these caps are really related to digital applications. What I am going to do though is just those two, because I know they definitely make a difference, specifically for the mic preamp section. The low frequency cutoff, which is right here, is like 110 hertz or something. So I put a bigger cap in here. It's basically double the size, which lowers the frequency a bit. Pretty much 80 hertz is where it's at. I've put this extra cap in here and slapped these guys back there. Changed out this chip, and now I want to change out these EQ chips. These chips have a sound, and I find that it's a bit colorful and not a way that I really enjoy. The best method that I've come up with is just sacrificing these chips, just snipping them off and then removing them pin by pin. Grab some very sharp wire cutters for this, preferably some that are very fine that you can get in close. On this circuit board, it's labeled conveniently what each chip is. So you have your high and low frequency EQ chip right there, high mid frequency EQ right there, low mid frequency right here. What I'm going to do is replace these with these little dip 8 sockets. So the sockets will go in there, and then I can change out chips pretty easily if anything happens where maybe one goes bad or I just don't like the results. I'd like to try out these Burr Brown OPA 2134 PA chips in those sockets. I haven't used them there before, and I think they probably will work. Normally I'll go for a Linear Technologies 1358. Okay, so the next step is to remove those. Once again, a desoldering station would come in handy here. What I've sometimes found is that it's best to heat it up with an iron and just pull the pin out with a pair of needle nose pliers. So maybe we'll try that real quick. Usually I heat up the pin and then just grab it. Like that. Once you get the piece of metal out of there, then it's way easier to use the desoldering station to clear the hole. I'll just go through and remove all of the pins with this method and then come back with the desoldering station. Here we have the VCA, which is a very important component on this mixing board and many mixing boards. The VCA in this situation is directly related to the faders, automation, or even dynamics, such as the compressors that are virtually controlled. It's a really cool thing, but this particular VCA is kind of outdated, to say the least. It's a that 2150A. At its time it was pretty good, but nowadays there's much better, the that 2180A. Now this is a very dangerous thing to be doing here, and I can tell you from experience that I screwed up a few of these to figure out the best ways to deal with it. But basically, we do not want to directly try to desolder this thing, because that has a high failure rate. So I'm just going to try to break it by flexing back and forth gently until the metal gives out. Okay, and off it goes. Great, now we can try to get those pins out. Just sacrificing this component is a lot smarter than trying to salvage it, because that's a lot of abuse to try to remove a component with that many pins that are that small and close together.
We're going to compare a stock Channel 11 from 1996 to a fully recapped and upgraded Channel 12. I have a pair of AKG C414B microphones that I'm speaking into. They are as close as can be to each other without touching. One mic goes into each channel strip. You're hearing my voice through Channel 11. Paul will now switch my voice over to Channel 12. Both channels are set with identical settings. We're running through the entire channel strip, meaning the full EQ and the fader-controlled VCA. The VCA also acts on the dynamics, but that's for a future video. Let's switch back to channel 11. Now we will disengage the input flip button, which bypasses the EQ and the VCA. This allows us to compare the difference of just the mic preamp, and now for channel 12. Even when comparing just the preamp, the difference in quality of sound is apparent. Now imagine if the whole mixing board had the sound of channel 12. That would be something special, wouldn't it? That's what I've got here at LBA on our Big 44. What do you think about the upgraded channel 12 over the stock channel 11? Could you hear the difference? Can you imagine what the console would sound like, fully upgraded and recapped? Please give us a like if you found this video interesting. Don't forget to subscribe and hit the notification bell to find out about the next video in the series, which is going to be about the console's power supply. It's getting a big upgrade. Stay tuned.
I know I'll never lose again. They say the slow and steady will